Okay, today we're going to talk about finding the surface area of a sphere. So right in front of us right here, we have a nice sphere. And what we've done is we've broken, or what we're going to try and do to figure this out is break up the sphere into 1,000 of these polygons. These happen to be pentagons. So imagine breaking up all of this into 1,000 of these pentagons. So if we have 1,000 pentagons, imagine the surface area being the area of the first one, the first polygon, plus the area of the second polygon, plus the area of the third polygon, all the way up to the surface area, or the area of the 1,000th polygon. So that doesn't help us very much. So let's take what we know, or what we've used before, to talk about um, how we can derive that area or surface area formula for a sphere. The last time we were together, we talked about volume. So we found out that volume is uh, of a sphere is 4/3 pi r cubed. Now, if you turn your attention back up here, and if you take a look at our polygon right here, and if you start connecting each vertice to the center of the sphere, this shape right here ends up becoming a pyramid. So if we think about finding the volume of that pyramid, what that really means is you're going to do, let's see, volume of a pyramid is 1/3 times the area of the base times the height. Now the height, since this is a sphere, the center of the sphere out to any point on the sphere is always the radius. So we're going to say 1/3 times the area of the base times the radius. Now the area of the base would be all of these pentagons put together. So I'm going to substitute that for S. That comes from right here. So times the radius of the pyramid. All right. Now we can take um, we could take this and also write it like this if we really wanted to. You could say the area of base 1 plus the area of base 2 plus the area of base 3 all the way out to 1,000, and multiply that by r. But I'm going to argue that it's going to be easier just to say call that S for surface area. Remember, we got that up here, uh, times the radius, which is the height of the pyramid. Now, if we take these two right here, and I notice that there's a V there, so I'm going to take this and I'm going to substitute that in there. In place of it, I end up with 4/3 pi r cubed equals, remember I'm substituting this in place of this, and then this goes right here, 1/3 times the surface area times the radius. Now if I want to go ahead and solve for S, remember S stands for surface area, I need to use some algebra. So if I want S all by itself, I'm going to divide this side by R, divide this side by R. That leaves me with 1/3 S on the right hand side. You notice this would be R to the first power, and so I have to combine these two. So that means I have 4/3 pi, and when you divide you have to subtract the exponent, so it's R squared. Next I have this fraction right here, and to get rid of that fraction I have to go ahead and multiply by its inverse. So I'm going to multiply by 3/1. And if I do that on that side, on the right side, I must do that on the left side. So over here, that cancels out this, leaving me with S, and 3 times 4 is 12. 1 times 3 is 3 pi r squared. And this simplifies to 4 pi r squared. And that is how we get the formula for surface area of a sphere. So if I just flip over here to the next page, here we have a nice conjecture, and you could go ahead and press pause, and you can add this now to your conjecture list. So that is where we get the formula for surface area of a sphere. Remember, you can rewind, you can watch this over and over again. You get Google surface area for sphere formula, and you would find more there too.